guys, welcome back to the quantity surveying workshop, and in today's video on taking off for quantities for substructure, we are going to be treating foundation trench excavation only. Now the thing taking off for substructure is that foundation trench excavation is the only section of the taking off list that requires calculation. Now the calculation we're going to be calculating here is not new to us because that calculation is the mean gate of the building. Now when we are measuring for foundation trench excavation, the units for foundation trench excavation is meter cube, and that meter cube consists of dimensions such as the guts of the building, the width of the foundation footing, and the height of the trench. Now we're going to be looking for each of these values, and that is what will make up our meter cube. Now, how do we calculate the gates of this our building here? Now, in the previous video, you noticed that the plan did not have internal walls. So in this video, I'm going to be showing you how to go about a building plan with internal walls. Now, the first thing we're going to be doing is to calculate the external gates of this building. And to calculate our external gates, we know that our out-to-house dimension for the length is 12,825 meters, and our width is 10,725 meters. So to calculate the gates, we'll now say the length is what? 12,825, and the width is 10,725. When you add them together, we are going to be having 23,550, and then we times it by 2, and we have 47,100. Now this 47,100 is the perimeter of the external side of the wall, but this is not what we're looking for. We're looking for the center line. So what do we do on the left 4 corners as stated in the previous video? That's 4 by 2 sides by half of the wall thickness, which is 225, and that will give us 900. Now when I less 900 from 47,100, it gives me 46,200. Now this 46,200 is the external gate of this building, but this building also has internal walls. Now how do we look for these internal gates? Now we are going to be taking this approach of finding the summation of the vertical walls, putting them one side, and finding the summation of the horizontal walls and putting them one side. Then we add them together. That will give us the total internal gates of this building. And once we've gotten our total internal gates of this building, we will add our total external gates and our total internal gates together to give us our total gates. And that is what we are going to be needing for the foundation trench excavation. Now, to solve the internal gates of this building, we are going to choose whether we're starting with the vertical walls or we're starting with the horizontal walls. So I am going to be choosing the vertical walls. That means I'm going to be starting with the vertical walls. If you look at this, you know that we've already calculated the whole external perimeter. What is left now is the internal perimeter. So now I'm going to be taking each vertical wall one by one, and I'm going to be adding them together. Now if you look at this, we're going to be taking this wall here, that's from here down to this side as our V1. So what's the dimension of this vertical wall? The dimension of this vertical wall would be the summation of 3,600, 225, 1,200, 225, 1,200, 225, and 3,600. When you add all these dimensions together, it will give us the length from this internal wall here, and we're going to be taking this our internal wall here as what? V1. We write V1 will now be equals to what? 10,275. Now we've taken this as our V1. I'm going to take this wall in from here to here as my V2, and the dimension is what? 3,000. It has this internal wall here, this vertical wall here. You know that in this substructure, as in the foundation, the block work is going to go around the whole plan. So all these spaces, we won't need them until we get to the superstructure. So just take it that the block work is running through here. So now we're going to take only the vertical side, which is from here to here, and the dimension is what? Giving us what? 3,000. So V2 is equal to what? 3,000. Now if we are taking this side as our V2, we'll take this side too, from here to here as our what? As our V3, and the dimension is what? 1,200. So we've taken this side, we've taken this side, we've taken this side. Now we're going to be taking from here to here, and I'm going to be calling it my what? V4. As this line like this, and the dimension is what? 3,600. So we've taken this side as our V4. Now we're going to be taking here like this, as from here down to here. That's this one here, and we're going to be taking this as what? How do we find it? That's 1,200, then plus this thickness here, then plus this 1,200. That will give me what? 2,625. So we write it down. V5, 2,625. Then the last vertical wall is from here to here. That's here, and the dimension is what? 3,600. So we'll take this as what? V5. We'll take this as what? V6. That's 3,600. Now, so we've found out all the dimensions for all the vertical walls. So what we're going to be doing now is to add them together. So the summation of V1 down to V6 will now give me 24,300. Now this is for the vertical one. The next thing now we're going to be doing is for the horizontal walls. Now let me use pencil to show the horizontal parts. Now let's start from here. This is a horizontal wall, so we know that from here to here is 3,300 as given. From here to here is 3,300, but there's a thickness here that we not cater for in the vertical. We only use the in-to-in dimensions for the vertical, so we're going to be adding all this wall thickness to the horizontal. So now we're going to be taking this horizontal wall here, this horizontal wall that I shaded is going to be our what? H1, and we know that from here to the internal side is what? 3,300. We're going to be adding this wall thickness of 225, and that will give me what? 3,525. So we'll take this as what? H1. $3,525. Now, after we've done H1, we go to the next one now, H2. We know that from here to the internal side is giving us what? 2,500, and the thickness is what? 225. So in order to find for the dimension from here to this side, we'll say 2,500 plus what? This wall thickness, which is 225, and that will give us what? That's 2,725. So H2 is equal to 2,725. Now this is H2. The next one is what? H3, and we are going to be taking our H3 from here to this side, because we took our vertical wall as this whole wall direct. So that means this horizontal wall will begin from this internal side of the external gate down to this side of this vertical wall. So that means the H3 would go like this. This is how the wall will pass. And what's the dimension of this H3? It is given as what? 5,525. Then we go to H4. So I'm going to be taking the whole of this wall as H4. That's from here to this end as H4. Let me shade it. And the dimension from here to here, how do we get that? We know that from here to here is what? 4,400, and this is a wall thickness of what? 225, and from here to here is 2,000. So we're going to be adding 4,400, 225, and then 2,000 to get the total dimension of this block. So that will give me 6,625. So H4 is equal to 6,625. Then we go to what? H5. So I'm going to be taking my H5 as from here down to this side. That's this whole wall like this. So it's starting from here down to this side, and you know that the wall we have here is equal to the wall we have here. So since we found that the dimension from here for this wall is 6,625, that means the wall from here to here is also 6,625. H5 will now be what? 6,625. Now we go for what? H6. Now what are the horizontal walls remaining? That's this one and what? This one up here. So now we've done up to H6. So we're going to be catering for this wall here, from here to here. And the dimension is what? 2,000. So H6 is what? 2,000. Then the last horizontal wall, which is from here to here. Will give me what? H7, and the dimension from here to here is what? 2,000. So I write H7 is equal to what? 2,000. So when I find for the summation of the horizontal walls, it's equal to 29,025. So this is the gates for the horizontal walls. So now to find our internal gates, we have to add the vertical wall and the horizontal wall together. So to find our internal gates, we have to add the horizontal gate and the vertical gate together. So we know that our horizontal gate is what? 29,025, and our vertical gate is what? 24,300. Add these two together and we have 53,300 and what? 25. This is our total internal gate. What we are looking for is the total gate. So we have to add our total internal gate to our what? Total external gate. So our total center line will now be equal to what? Internal gate plus what? External gate. And our internal gate is what? 53,300 and what? 25. And our external gate is what? 46,200. When you add them together to give us what? 99,500 and what? 25. And this is our total gate. Now after we found our gates, the next thing we're going to be doing is what? We're going to be calculating the height of the trench. If you look at this diagram of a foundation footing, what we are interested in is to look for the height of this trench, that's from here down to this footing. So in order to do that, we know that from here to the top of the footing is given as 1,100, and the depth of the footing is 225. So that means the height of the trench is 1,100 plus what? 225. So we'll say depth of foundation footing. Know that the height is 1,100. We add the thickness of the foundation footing, which is what? 225. And it's going to give us what? 1,325. But if you remember, in our previous operation of removal of topsoil, we've already removed 150 mm topsoil. So this foundation footing is not commencing from the natural ground level. This is the natural ground level. Let me just write it, NGL. We have already removed 150 from this natural ground level. So that means the foundation trench is not starting from here. It is starting from this level here, which is called the stripped level. So the level after you've removed your topsoil of 150 mm is called the stripped level. So that means the foundation trench is starting from here. Stripped level. So we are going to be what? Minusing that topsoil that we've removed. That's topsoil of what? 150. And that will give us 1,175. So this is the depth of the foundation footing. Now, after calculating all this, you know that the width of our foundation footing is what? 625. So the next thing you're going to be doing now is to describe. So we'll say excavate foundation trench not exceeding 2 meters deep, commencing from stripped level to suit strip foundation. Then we what? Do what we call handing on. Now, the reason why we are going to be doing this handing on is because there's an operation that comes after you excavate the foundation trench. Now, after you excavate the foundation trench, let me use this diagram. After you've excavated this foundation trench like this, and you've laid your what? Your foundation footing, and you've put your block work, you know that we're going to be backfilling. We're going to be putting back this. We're going to be covering this spread here with sand. We have to cater for it here. So we're going to do what? Add backfilling. Of excavated materials. And add material surplus. So this is the description for excavation of foundation trench and what? The backfilling. So what we're going to what? Close. After closing now, we're going to what? Put down the measurement. And we said that foundation trench is measured in what? Meter cube, which is GAT, and our GAT is what? 99,525. You convert it to meters, it will give me what? 99.5. The width of the foundation fitting is what? 625. That's this. From here to here is 625. So we convert it to meters, it will give me what? 0.63. And the height of the foundation trench is what? 1,175. Convert it to meters and we get 1.18. And then you close. So this is this for excavation of foundation trench. I hope you enjoyed the video, and if you had adequate knowledge from it, please like, share, and also subscribe to this channel. Thank you.